All right, we have some new principles in this section. We have the fundamental counting principle. It's a number of ways an event can occur. So if we have, for example, here, a person needs a 4-digit PIN, how many possible outcomes are there for the PIN? So if we have 4 digits, there's 4 blanks, okay? A digit is a number that's 0 through 9, right? 0 through 9. So there's 10 possibilities because 1 through 9 and then 0 makes 10. So there's 10 possibilities for each of these. It doesn't say anything like they can't be repeated. It could be 1111. It could be 5522. There's 10 possibilities for every single spot. So what we do is we multiply the number of possibilities for each spot together, and we get 10,000. So there's 10,000 possibilities for that PIN. Okay. Example 2. It says this restaurant offers a 3-course dinner menu. Customers who order from this menu must choose 1 appetizer. So we've got 1 blank for the appetizer, 1 blank for the main dish, and 1 for dessert. So out of our appetizer list, there's 3 options. Out of our main dish, there's 4 options, and out of our dessert, there's 2 options. So we would just multiply all those numbers together, 3 times 4 times 2, which gives us 24 possibilities of different meals that could be ordered. Okay. Factorial formula, the number of arrangements of an entire group. So when something says n factorial, it means you take that number and you multiply it by every number smaller than that until you get to 1. Okay, we're only using our counting numbers. So 4 times 3 times 2 times 1. If it's 3 factorial, you start at 3 and you work your way down. 2 factorial, same thing. So your calculator will actually do this for you too, depending on what calculator you have. So on these calculators, if you look above the 3, it says X exclamation mark. So if I wanted to do the first one, I would type the number 4, and then I would hit the second button, and then the 3, and it gives me my answer is 24. Now, when you just have a small number like that, you could just multiply all these together and get 24. But if you had a bigger number, it would be way easier to just use your calculator. So same thing here, I can just do 3 times 2 times 1, which I know that's going to give me 6, but if I'm not sure, I could check it on my calculator and get 6. Okay, 2 factorial is just 2 times 1, which is 2, but if you want to practice using your calculator again, you type in the 2, and you hit second 3, and you get 2. And then 1 factorial, it's just 1. And this one's kind of weird. It's a special case. If you have 0 factorial, it's 1. Okay. What is the value of 5 factorial? So I'm just going to type that in my calculator. I'm going to type 5, and hit second factorial, and I get 120. Okay. And then it says, how many different ways can 8 people sit in a row of 8 chairs? So you could write out your work for this, or just do 8 factorial. Again, you can use your calculator for that. So 8 second 3, and I get 40,320. Now if you think about what this means, 1, 2, 3, 4, 5, 6, 7, 8. If these are my 8 chairs, I have 8 different people. So this chair would have 8 options, but now I've used 1, so then I have 7 options. Now I've used the second one, so I have 6. A third one I have 5, and I'm going down 1 for each. That's why this is an 8 factorial question. Okay, because we have 8 people that need to sit in 8 chairs, so every time you move a chair over, you're getting rid of 1 person because somebody already sat down. Okay, the next vocabulary word is on the bottom of this page, but the formula is on the top of the next page. It says permutation, an arrangement of outcomes where order matters. And that is super important. Okay, so at the top of your next page, since it printed weird, I'm going to write that again at the top because It's really important. Okay, order matters. So there's a formula for it, but great news is that in this formula, you don't have to memorize it because your calculator will do it for you. Okay, this is what you do have to know. You have to know that the number of objects comes first and the number in the subset comes second. So it basically means like this is like your total. How many things are you picking from? And this number is how many you pick. Okay, and it'll make more sense when we do an example. It says a youth baseball team has 15 players, so this is our total, so that's our N. How many different ways are there for the team's manager to select and arrange 9? So this is our R, because that's how many we're picking to make up the team's batting order. So when we write this down, we're going to write 15P9. Okay, I have 15 that I can choose from, and I'm choosing 9 of them. So in your calculator, you're going to find the button that looks like this. Okay, on this calculator, it's above the 9, and it's in green. Okay, the order you type the numbers in is the exact order that you're going to see here. So I'm going to type 15 first, and then I'm going to hit the P button. So I hit second, 9, and then my second number is 9, and then I hit equals. It's a huge number. Okay, so we're going to write this number down. We've got 18162144400. Okay, so this is thousands, millions, billions. Okay, so there's over 1 billion different ways they could make the batting order. Okay. Number 6, how many ways can a club select a president, vice president, and secretary from a group of 5 people? So there's 5 people, that's your total, so that's your N. How many things are we picking? We're picking a president, a vice president, and a secretary. We're picking 3 things, so my R is 3. So when I write this down, it's 5P3. So in my calculator, my steps are going to be hit the 5, then hit the P button, so you hit second 9, and then 3, and then equals, and you get 60. So there's 60 different ways president, vice president, and secretary can be picked. Okay. A combination, a grouping of outcomes where order does not matter. Okay, where order does not matter. So you'll see this button on your calculator as well. It's right next to the other one that we talked about. It's above the 8. Okay, the N and the R mean the same thing that they meant in the other problem. It says New Jersey Pick 6 Lotto game. A player chooses 6 different numbers from 1 to 49. The 6 winning numbers for the lottery are chosen at random. If the player matches all 6 numbers in any order, she wins the jackpot, which starts at $2 million. How many different possible sets of winning numbers are there for the New Jersey Pick 6 Lotto game? So we're picking 6, so that's our R. They go from 1 to 49. So that's our N. So our N is 49, and our R is 6. So since the order doesn't matter, because it says it's at random in any order, we're going to do 49C6. So again, in our calculator, we type the 49 in first. We hit the second, and this time we're using the C, so we hit the 8, and then 6 equals. So 13,983,816. Example 8. At the end of a week-long seminar, the presenter decides to give away signed copies of his book to 4 randomly selected people in the audience. How many different ways can this be done if 30 people are present? So we have to think to ourselves, which one's the total? Well, the 30 is the total, so the 4 is the R. So 30C4. And this is what we're typing into our calculator. 31st, and then second 8, and then picking 4 equals, we have 27,405. And then the rest of the problems are for you to practice. So one thing to be really careful about is to try to decide if order matters or not when we're doing permutations and combinations. Okay, if we look at some of the questions, we have to decide if we're just using counting principle or if we're using permutations and combinations. So these 3 questions, this is just our counting principle. So that's like that very first problem that we did. And then these questions are going to be deciding if it's permutation or combination. In permutation, the order matters. Okay? And then the next set of problems you actually are solving. So again, you're going to have to decide permutation or combination and then solve it. Okay, these you're just saying permutation or combination.